Hi, hi everyone. I'm Eglin Juno BK, Assistant Professor in Department of Biomedical Engineering at Emmanuel Research JJ College of Engineering. So today we are going to study one of the most important topics in sensors and measurement, namely classification and the characteristics of transducers. Almost every biomedical instruments, whether it is an ECG machine, blood pressure monitor, pulse oximeter or ultrasound scanner, etc., uses sensors and transducers. Therefore, understanding this topic is essential before studying biomedical instrumentation. During this class, we will learn what sensors and transducers are, how they are classified, and their important characteristics, also their biomedical applications. Okay. Before we discuss transducers, let us first understand what is measurement. Measurement is the process of determining the value of physical quantity using a suitable instrument. Okay, value of physical quantity using a suitable instrument. Example, physical quantities include temperature, pressure, displacement, force, light intensity, etc. Okay, these physical quantities are called as measurand. Okay, these physical quantities are known as measurand. The sensor detects these physical quantities. However, the detected value cannot be processed directly by the electronic system. Okay, yes, therefore a transducer converts the physical quantity into an electrical signal that can be displayed, stored or analyzed. Okay, this conversation process is the reason why transducers are considered the heart of every biomedical instrumentation. Okay, now we move to what is sensor. Okay, a sensor is a device that detects or senses a physical quantity. The sensor itself only detects the parameter. For example, a temperature sensor detects the heat, a pressure sensor detects the pressure, likewise a light sensor detects light intensity. Okay, the sensor produces information based on the physical quantity it detects. Okay, in biomedical engineering, sensors are present in almost every instrument. For example, the pulse oximeter uses optical sensors. ECG uses electrodes sensing elements. Also, in digital thermometer, use temperature as sensor. Nowadays, wearable sensors like smartwatches also contain multiple sensors. Okay, these sensors continuously monitor the heart rate, oxygen level, sleep pattern, and physical activity also. Okay, now we understand what is sensor, and let us move to what is transducer. Okay, now let us move to the word what is transducer. A transducer is a device that converts one form of energy into another form. In biomedical engineering, most transducers convert physical energy into electrical energy. For example, temperature becomes voltage, pressure became electrical signal. Likewise, displacement became resistance, also light becomes electrical current. This electrical signal is then amplified, processed and displayed or stored. Okay, think about a normal digital thermometer. The sensor detects the temperature first. Okay, then the transducer converts the temperature into electrical signal. Okay, can you able to follow me? Once again I am repeating. In our normal digital thermometer, the sensor initially detects the temperature. Okay, then the temperature is converted by the transducer as electrical signal. That is, transducer converts the temperature into electrical signal. Then the electronic circuit processes the physical parameter. Okay, finally the display shows the temperature. So the transducer acts as the bridge between the patient and electronic system. Okay, because the transducer only converts the physical parameter to a electrical signal. Okay, so now you can understand the difference between sensor and a transducer. A sensor only detects the physical quantity. The sensor only detects the physical quantity, but the transducer converts the detected quantity into another usable form. usually an electrical signal. Okay, for example, a pressure sensing element detects pressure. A pressure transducer converts the pressure into voltage. Similarly, the ECG electrode senses the electrical activity from the body. The ECG system converts into the signals that are displayed on the monitor. So every transducer contains a sensing element, but not every sensor considered as a complete transducer. Okay, remember this point because it is very important. Okay, now we all know about the sensor and a transducer. Now let us understand how a measurement system works. Okay, every measurement system has several stages. The first stage is a measurand. Okay, already I said what is measurand. The physical parameters are known as measurand. Next comes the sensor, which detects the physical quantity. The detected information is then passed to the transducer, which is converted into electrical signal. However, this electrical signal is usually very small and may contain noise. Therefore, it goes through a signal conditioning unit, where it is amplified, filtered and processed. Finally, the processed signal is shown on a display or stored in a recorder. Okay, for example, in a digital thermometer, measurand, that is body temperature. Then sensor, temperature sensing element. Transducer converts the temperature into electrical signal. Then the signal conditioning process the signal and display the value. Okay, the same principle used in almost all biomedical instruments. Okay, so next we move to the importance of the transducers. You may wonder why we cannot measure everything directly. Okay. Modern medical equipment works electronically. Okay, all modern medical equipments works electronically. Computers and monitors cannot understand the temperature, pressure or the force directly. They only process electrical signals. Okay, so the transducers converts these physical quantities into electronical signals and making them suitable for electronic systems. Okay, transducers help us to improve the accuracy, reduce the human error, enable continuous monitoring, also store patient data and trigger alarms during emergency. Okay, imagine an ICU without transducers. Doctors would not able to monitor heart rate, oxygen level, blood pressure or respiration continuously. Okay, that's why transducers are called the heart of biomedical instrumentation. Okay, that's why the transducers are called as heart of biomedical instrumentation. Okay, next, what are the classification of transducers? There are many types of transducers because different applications require different operating principles. Okay, different applications require different operating principles. The most common classifications are active and passive transducer, then the analog and digital transducer, then the classification based on the principle of operation such as resistive, inductive, capacitive, piezoelectric, optical and thermal. Okay, we will now discuss each type one by one. First one is active transducers. Transducers are first classified as active and passive. An active transducer generates its own electrical signal, that is, its own electrical signal does not need an external power supply. Active transducers generates its own electrical signal and it does not need the external power supply. For example, a thermocouple produces a voltage when there is a temperature difference. Okay, when there is a temperature difference. For example, once again I am repeating the example. A thermocouple produces a voltage when there is a temperature difference. Okay, a piezoelectric transducer generates electricity when the pressure is applied. A piezoelectric transducer generates electricity when pressure is applied. Okay, in opposite case, that is passive transducer requires an external power source. It does not generate electricity by itself. Instead, the physical quantity changes its resistance, capacitance and inductance. Okay, the physical quantity changes its resistance, capacitance or inductance. For example, that is strain gauge, LVDT, RTD, examples. Okay, passive transducers generally provide better accuracy and sensitivity. but need additional circuitry. Okay. Just think of a device that works even without a battery. That is an example of self-generated energy. Okay, that is an example of self-generated energy. Okay, next, the another classification based on the type of output, that is an analog transducer and a digital transducer. Okay, an analog transducer produces a continuously output signal. The value changes smoothly without the input. The value changes smoothly without the input. For example, if the temperature increases gradually, the output voltage also increases gradually. If the temperature increases gradually, the output voltage also increases gradually. The digital transducer produces discrete values, usually in binary form. A digital transducer produces discrete values, usually in binary form. These are commonly used in modern medical equipment. These are commonly used in modern medical equipment because digital signals are easier to process, store and transmit. Because digital signals are easier to process, store and transmit. Examples include digital temperature sensor, optical inputs, and many smart sensors used nowadays in as a smartwatches, wearable devices, etc. Today, most hospital monitoring systems use digital transducers because they provide higher accuracy and compatible with computers. Okay. Just think, which type of output do you think easier for a computer to process? That is analog or digital? Okay. Digital is easier to process to computer, correct? So next we move to the what are the applications based on these transducers. Okay. Okay, before the application, let us classify transducers based on how they work, or which is called the principle of operation. Okay, first one, resistive transducers. These work by changing electrical resistance when a physical quantity changes. Example, strain gauge. Okay, when a force is applied, the strain gauge stretches or compresses, changing its resistance. This change is measured and converted into electrical signal. Okay, in this application is measuring force in prosthetic device and pressure sensors. Okay, the next one is inductive transducers. These work by changing inductance. Example, LVDT, that is linear variable differential transformer. It is commonly used to measure displacement with high accuracy. The biomedical applications of inductive transducer is measuring movement in rehabilitation equipment and precision medical instruments. So the next one is capacitive transducers. These work by changing capacitance. Okay, when the distance between two plates changes, the capacitance also changes. The biomedical applications of capacitive transducer is measuring pressure, displacement and touch in medical devices. Okay. Piezoelectric transducers. These generate electricity when the mechanical pressure is applied. Okay. The biomedical applications of piezoelectric transducer is ultrasound imaging. The ultrasound probe uses piezoelectric crystals to produce and receive ultrasonic waves. The next one is optical transducers. These use light to detect changes. Okay, that is pulse oximeter, where the red and infrared light measure oxygen saturation in blood. Okay, the final thermal transducers. Okay, they respond to changes in temperature. Example, digital thermometers, incubators and the patient temperature monitoring system. Okay, each type is chosen based on the quantity being measured and the required accuracy. So the next one is characteristics of a good transducer. What is the characteristics of a good transducer? When selecting a transducer, engineers look for certain desirable characteristics, that is accuracy, sensitivity, linearity, stability, fast response. That is in critical care, the sensor must respond immediately to changes in patient's condition. Okay, also reliability, low power consumption, etc. A good transducer combines all these characteristics to provide accurate and dependable measures. Okay. Finally, what are the biomedical applications of a transducers? So ECG. In ECG, electrodes detect the electrical activity of a heart and converts it into electrical signals that is displayed as an ECG waveform. Like also EEG, electrodes detect brain electrical activity. EMG measures the electrical activity of the muscles. Also the pulse oximeter, blood pressure monitor, ultrasound scanner, digital thermometer. In digital thermometer, thermal transducers is used to measure body temperature accurately. Without transducers, this medical device would not be able to collect patient data. Okay. So today we learned the measurement is the foundation of biomedical instrumentation. We should understand that the sensor detects the physical quantity while transducers convert into electrical signal. We discussed different classification, that is active and passive, analog and digital, and finally based on the principle of operation, transducer are classified as so and so. Okay. So we also learned the characteristics of good transducer and saw its application in medical devices like ECG, EEG, ultrasound, pulse oximeter, digital thermometer, etc. These concepts are fundamental with help and you understand many other biomedical instrumentation. Okay. Okay. Thank you all for your attention.